The Excel steps is a little bit different. Like for the R and Python, you pull in the iris data, which is a well-ingrained data set in both languages, and then you're doing some visualization and like correlation and scatter plots, and then running a decision tree, which you could probably just pull the same steps you did for the mushroom data set. So that shouldn't be too bad. And then the clustering, and I did provide some more resources on clustering for R, because I'm not sure that in the last class or earlier in this class we've done clustering. So I did provide some links there. So that's what the languages are doing. For Excel, you can't do you can't very easily do decision tree. Like Excel is less powerful, obviously. So it's more focused on the process of clustering. And I actually like this exercise because I think it forces you to understand how correlation works and what that algorithm really looks like. So this is obviously a very simplified run through of that algorithm, but you can kind of see how it takes the data points and, kind of assigns them and shifts the centers around to get the best groupings with that minimum distance. So I do like it, but I recognize that the tutorial, while it does cover every step, sometimes it's easier to see it on a screen. So I just wanted to walk through what that might look like for you if you were to follow along with the tutorial. So this is the iris data set. The first thing that I did is run correlation, and you can find correlation under data analysis. It's right here. And then you would run that and select your data. You'd tell it that you have the variables selected, and then it spits out a nice correlation matrix. So that part's pretty straightforward. And then I chose, you're looking for the two variables that are the highest correlated. So we have petal length and petal width. So we're going to use those. And we're going to start from there and pick our centers. So for the centers, I just calculated the min, the median, and the max for the petal length, and then found those values in my data set and made those my initial centers. So there's one of them, there's the median, and there's the min. So I'm picking those. I think there's a couple of the median, maybe there might be more than one data point that you could pick. Like I think you could also do this one, and it's fine. You're just trying to get your initial clustering. So your centers might be slightly different, but the process is still going to be the same. Okay, so we've picked our variables. We've found our initial centers, and I pulled those. I didn't need to do this, but I like to, I try not to, I'm already referencing other sheets, but the way I broke this out into steps. So I'm trying not to reference other sheets too much when you look at the formulas. So that's why I moved my initial cluster center points up here. So this is the length and width, length and width, and length and width. Did I do that right, or did I switch them? Yeah, length and width. So then I'm going to use those. Those are from my data tab. Those were my cases associated with min, median, max. And the reason why we do that is because if we pick the min, median, and max, it kind of spreads out our initial centers, which helps with the minimizing the error right off the bat for the clustering. So then we're using, and I put this note here, we're using the SumX my2 formula in Excel, and it's basically going to do all the calculation we need for us. So all we need to tell it is our data point, which is, so this is case 1. So if we went back to our data set, it's case 1 right here, and our center. So in this case, our center right here. And I fixed that point because I'm just going to drag my formula down, and I don't want it to, I want it to stay on columns D and E, but I don't want it to stay on row 2 because I want it to go down by a case. So as I pull the formula down, it goes to row 3, 4, 5, all the way down to 150, whatever, 1. And then, but I don't want this to change. I want it to calculate for every point the distance between that center and the the data point and the center that we picked. So I'll do that for, so you can see it, as it moves down the cases, but it keeps the center the same. And then it's the same formula for clusters 2 and clusters 3, except that our center is the centers related to those clusters. So it looks complicated, but it's more just about how you organize your calculations. And then from here, we just pull them in for each row. And then, so the min for this row was cluster 1. And then we just use an if statement. And it'll have to be nested, but we'll take our if statement, and then that will tell us if the min is equal to this, then we choose cluster 1. If it's equal to 9.62, then we would choose cluster 2. And if it were equal to that, we would use cluster 3. So you can see as we go down here, oops, these are associated with cluster 2, and then you see some 3s and 2s mixed in as well. So, and our SSE is going to be, the sum of the squared error is going to be apparently nothing because my Excel is locking up. Just the sum of the minimums. Okay, so that's our initial run with our initial clusters. But now we want to do our actual centering. Yeah, so we're going to pull our data from each case if the cluster matches. Otherwise, we're going to leave it blank. So in this case, if A is equal to cluster 1, then we pull the data from row 1. This says if A is equal to cluster 2 is equal to 2, then we pull the data from case 1. Or if it were equal to 3 here, we would pull that data from case 1 for the petal length. Same with petal width. So since this is 1, only the data here populates, and then the if formula says if it doesn't match, just put in blanks. So that leaves those blanks. So we're basically like parsing out our data into clusters 1, 2, and 3. And so this will make it nice for us when we go to do our graphs, but then we can also calculate the means for all of these now. And these would be our new centers. So if we wanted to see if our clustering improved, we would run a validation on that. So basically same process as before with the sum x and y2, but at this time we're using our data from case 1, but now we're using our, and I should have pulled them over. I don't know what, I did it in the 1, but not here. We're using our new centers here. So, and then for here, we're using our new centers here instead as our second point. So that was initially these points. And now we're just running the same calculation, but with these points to see our new, to basically get our new SSE. And once we do that, we get our new SSE. It's lower. It was like 80 something. So that's good. And then all we need to do now is plot our results. So I just pulled over the, I just stacked them 1, 2, 3, from here, and then get rid of the blanks, obviously. And then you can plot it. So if you plot it, it will look like this. And this is pretty dang good. You can see the clusters look, you know, pretty separated. So so those are the steps for our Excel file. And again, if you need to go back and watch that slower, you're more than welcome, but that should walk you through each step. And I hope that's helpful to see it kind of piece by piece, as opposed to kind of more high level explanation in the article. But these are the same steps. They're just, I just split them out for you guys so I can walk through them and show you the formulas. So I hope that's helpful. I need to plug in my computer really quick, so give me 1 second. Any questions about that?
No, it's just awesome looking. That's all I can say.
Oh, thank you. Yeah, Boris, I left a note on your thing. I don't know if you saw it. Did you find the tutorial easy enough to follow, or did it take you a lot of like back and forth?
I actually replied to you, and you know what I did? I actually found the video version of the guy going through each step through the video. So
okay.
that was really helpful.
Okay, cool. Yeah, in the future, I'm just gonna cut out the walkthrough I gave you guys and post that in the thing. So I think this is the only the second time I've used that assignment, so I don't have my own walkthrough of it. But I think last year no one used Excel, so I didn't need to explain it.
But it took a while to kind of grasp the concept, but since it was on the video, I just was going back and forth. So it was
okay, good. I hope it helps for the other students and for me to post that, and then I'll have it forever. So I appreciate you guys walking through that with me. Rana, do you feel like that was helpful?
I will try to follow your instruction to do my. So if I have a question, I will send it out to you. Yes.
Yeah, I think it looks a little intimidating, but the process itself is it's pretty repetitive. So once you kind of get started on it, and you're you know, oh, I see, I'm basically, you're just, you know, finding these distances between these points and the centers, and you're trying to move that center a little bit each time. And if you were to repeat that like more, which would be cruel for me to ask of you, but if you were to keep going, it would, you know, eventually you'd find that the centers like barely move and the SSE barely changes, all like imperceptibly. And that's all that like Python or R are doing. They're just iterating through until it converges, and then to the minimal error, and then it's a big optimization problem basically, and then it spits out, you know, whatever that iteration was at the end that gave you that optimized minimal error. So yeah.
So I never used this method before with the Excel. I use it with the R program. It's more easy. Now yes. I feel bad because I didn't select R.
Oh, well, I mean, you're like I said at the beginning, you're always more than welcome to flip between two like each week. So it's definitely easier in R and Python because they're doing all of that for you. But like I said, I kind of like the Excel version because you get to walk through the steps in your mind. And so if clustering seems like kind of a nebulous concept to you, it will be more like cemented, I guess, like how it works because you got to go through. So it's more, I see you shaking your head. Do you agree with that?
Oh, yes. So yeah, maybe this is a new thing for me. So I know it's a challenge, but I will go through it to see what I
Yeah,
can
yeah.
do.
Let me know, if you need anything else. I'll happily